Okay, so in the last video we looked at the standard form of a quadratic. Now we're going to look at factored form of a quadratic. So that takes on this general form here. A is what we would consider our GCF that was factored out, and then we have our factors of x minus p, and then what we're calling x minus q. Well, if it's in factored form like this, we know that if we're trying to find the roots or the x-intercepts, that means we would make our y 0. Well, if we set our factors equal to 0 and we solved, we would get x equals p and x equals q. Okay, so recall it's going to be the opposite sign of what you see inside there. Okay, so that means our x-intercepts are at p comma 0 and q comma 0. All right. If this were x plus p, if this were x plus q, then your roots would be at negative p and negative q. Okay, so it's the opposite sign. The axis of symmetry. This is found by simply taking the average of your roots. So if your roots are p and q, add them together, divide by 2, you're going to have your axis of symmetry. That's because the idea is if this is our parabola, all right, and let's suppose we have a root right here, and we have a root right here. This is the x-axis, okay? Our axis of symmetry, okay, remember that's going to go through the vertex, that is going to be in between your roots, okay? So it is always going to be the average of your roots, okay? So let's take a look at an example. Okay, so in this example, let's suppose we are given a quadratic in standard form, and we're trying to find the roots as well as the equation for the axis of symmetry. Well, we're not going to be quick to use the quadratic formula because this is factorable. Okay, so always try to first factor it. Well, we can pull out a GCF of negative 3. If we do that, we're left with x squared minus 3x minus 4. We can further factor this. This would become x plus 1 and x minus 4. Okay, so notice now it is in what we call factored form. So if we are going to find our roots, we know we're going to make y 0. Okay, and then we're going to set our factors equal to 0 and solve. Now when we do that, this will give us negative 1, and this piece will give us positive 4. Okay, this negative 3 here, if we were to try to set negative 3 equal to 0 and solve for x, do you see what the problem is? Hopefully you're thinking there's no x to solve for, so that is not going to produce an additional root. Okay, so our roots are at negative 1 and 4. Okay, those are our so-called p and q values. All right. If we needed the coordinates, we would write it like this. Okay. And lastly, our axis of symmetry. Well, we know this is going to be the average of our roots. It's always going to be in between the roots. And recall in standard form, the equation was negative b over 2a. All right, so, but don't forget it's always x equals. All right, so in this form, we're not doing negative b over 2a. We're just taking the average of those two roots, and if we do that, we're going to get 3 over 2, okay, or 1.5. All right, so x equals 1.5 is our axis of symmetry. Now, if you want to compare it to the x equals negative b over 2a, let's do that just to confirm we get the same thing. So using x equals negative b over 2a, so we would have to go back up here and pick out our a and our b value. So negative b would become negative 9 all over 2 times our a. Our a is negative 3. That gives us negative 9 over negative 6, which is 9 over 6, or 3 halves, which of course is the same as what we got when we found our roots. Okay, so of course you're not going to be expected to do it multiple ways, just showing you that you will get the same thing in the end.